Solving one-step equations with Mr. Pi, the math guy. Yeah, that's me. I'm Mr. Pi and I'm the math guy. Let's take a look at this math video lesson today on solving one-step equations. I got two things written down over here. The first thing is to isolate the variable. When you're solving equations, whether it be one-step or multi-step equations, the overall goal is to isolate the variable, and that is to find the value of the variable. I want you to understand that I'm going to be talking about the left, right, and the middle of an equation today. If you take a look at this example I have over here written down on the left, the original equation is x plus 2 is equal to 4. On the left of the equation is this algebraic expression, x plus 2. The middle of the equation is the equal sign, and on the right of the equation we have the number 4. To achieve our goal of isolating the variable, we must get rid of this plus 2. What you should know from previous math lessons is that the opposite of plus 2 is subtract 2. We're going to talk about why or how we could justify that in our work in the next slide, but let's just take a look at the fact that I subtracted 2 from both sides of the equation, both the left and the right, the middle being our equal sign. And you can see here I used a dashed orange line to indicate the middle of the equation, or the equal sign. Now on the left hand side, the plus 2 and the minus 2, they will cancel out. They become 0. So we've isolated the variable x. On the right hand side, we do the calculation 4 take away 2 to get 2. So after we isolate the variable in this problem, the solution is x is equal to 2. I have it written down over here because here's an alternative way that you may be taught how to solve an equation. Instead of writing your work underneath the equation, you rewrite the equation by subtracting the 2 from each side in this manner, in a more of a horizontal manner versus a vertical manner. So let's take a look at some examples here. I hope you find this video lesson interactive today. I'm going to do a few examples, and then you're going to have an opportunity to do some examples and then get the correct solutions to see how you did. Solving one-step equations. When you're solving one-step equations, you really need to worry about the properties of equality that will be involved in the given equations. And for this lesson, we're going to be focusing on the addition property of equality and the subtraction property of equality. The addition property of equality states, for all real numbers a, b, and c, if a is equal to b, then a plus c is equal to b plus c. What this tells us is, whatever you add to one side of the equation, you have to add to the other side. You have to maintain the balance. If you imagine this as a seesaw, if it's a little seesaw, whatever you do to the A, you also have to do to the B to maintain that balance, that equality, if you will. If we take a look at this little example here, x minus 4 is equal to negative 12. To solve this equation, we're going to use the addition property of equality. The reason we're going to use addition is the variable has 4 being subtracted from it, and the opposite of subtracting 4 is adding 4. So here we'll add 4 to both sides. And on the left-hand side, the minus 4 and the plus 4, because they're opposites, they cancel. They technically become 0. But since they become 0, that leaves us with the x on the left-hand side of the equal sign. And on the right, we have to do this calculation, negative 12 plus 4, and you should know that that's 8. So we saw here an example of using the addition property of equality to solve a one-step equation in which the original equation had subtraction. On the opposite side of that, we have the subtraction property of equality, which states, for all real numbers a, b, and c, if a is equal to b, then a minus c is equal to b minus c. Again, whatever you do to the left, you have to do to the right to maintain that balance. And again, if you imagine that as a little seesaw, whatever you do to one side, you have to do to the other side. So for this example, we have x plus 2 is equal to 7. To isolate the variable x, we have to get rid of the plus 2. We use the subtraction property of equality. A little malfunction there. The subtraction property of equality to get rid of the plus 2 so we can isolate that variable x on the left of the equal sign. And on the right of the equal sign, we do 7 take away 2 to give 5. So there were two examples just explaining the addition properties and the subtraction properties of equality. Solving one-step equations. What I'm going to do is I'm going to take the next few minutes to solve these three equations. When I'm done doing that, you'll have an opportunity to solve three problems similar to these problems to see if you understood the concepts. You'll see where the interactive part of the video comes in very soon. Let me model how to do these problems. In the first example, we have x plus 4 is equal to negative 7. Remember, we've been focusing on the idea of isolating the variable x. Sometimes, and I've seen some teachers do this, they even box off the x to give you an idea that's what you have to isolate or get by itself. Now, by itself, what we mean is the middle of the equation is the equal sign. Looking at the left, we have to get rid of a plus 4. The opposite of plus 4 is subtract 4. Using the subtraction property of equality, I subtract 4 from both sides. The 4's on the left, because they're opposites, they become 0. They cancel, they go away, isolating the variable x. I should bring down my equal sign. Now on the right hand side, I have to do negative 7 take away 4. Negative 7 take away 4 is a negative 11. If you're not sure how that solution is negative 11, then you should learn and find a lesson on adding and subtracting positive and negative numbers. Moving on to example 2, on the left of the equal sign we have x minus 5.2. To isolate that variable x, we're going to have to get rid of minus 5.2. To do that, we have to add 5.2 to both sides. We use the addition property of equality to do that. Now, on the left-hand side, remember, these numbers become 0. They go away, isolating the variable x. And on the right-hand side, we have to do this calculation, negative 7.8 plus 5.2. Since they are opposite sign numbers, we subtract their absolute values. So 7.8 take away 5.2. 8 take away 2 is 6. And 7 take away 5 is 2. The decimal is going to be between them. The absolute value of negative 7.8 is greater than the absolute value of 5.2. Therefore, the solution is negative. Here, I use the addition property of equality to solve the equation. Problem number 3 here is x plus 3 2/5 is equal to 9. Since we are adding 3 2/5 to the variable x, we're going to need to subtract that from both sides. So in this problem, we're going to subtract 3 2/5 from both sides. The 3 2/5 on the left, they become 0. They cancel. So we've isolated the variable x on the left of the equal sign. Now on the right, we have to do some math. 9 take away 3 2/5, we have to actually rewrite 9 as 8 5/5. 8 5/5. 5/5 is 1, so 8 5/5 is the same as 9. And then I subtract. I subtract the parts, the fractions. 5/5 take away 2/5 gives 3/5. And then I subtract the wholes. 8 take away 3 is 5. So the solution for number 3 is x is equal to 5 3/5. But we can see in each example, I either use the addition property or the subtraction property of equality to balance the equation to isolate the variable x. What you're going to do is pause the video and time yourself and solve these three problems. What you're going to do is pause the video, time yourself, solve these three problems. When you're done, continue the video to get the solutions and see me work out the solutions. What you should do is when I work out the solutions at the end, check to see how you did. comparing your work to my work to see how accurate your work was. So, when you solve this first equation, x plus 5 is equal to minus 11, what you should recognize is that this on the left-hand side has plus 5 with the variable x, so what you'll need to do is subtract 5 from each side. When you subtract 5 from each side, on the left-hand side of the equal sign, these 5's cancel because they become 0, leaving you with x. Bring down your equal sign. On the right-hand side, you have to go negative 11 take away 5, which gives negative 16. Did you get that problem right? Moving on to problem number 2. X minus 3.7 is equal to negative 9.9. What you have to do here is recognize that x has 3.7 being subtracted from it. The opposite of subtract is add, so we use the addition property of equality to add 3.7 to each side. On the left-hand side, the 3.7's, since they're opposites, cancel, leaving x on the left. And on the right-hand side, we have to do the calculation, negative 9.9 plus 3.7. They are opposite sign numbers, therefore we subtract their absolute values. So 9.9 take away 3.7. 9 take away 7 is 2. The decimal place goes right there, and 9 take away 3 is 6. The answer is going to be negative because the absolute value of negative 9.9 is greater than the absolute value of positive 3.7. So the solution here is x is equal to negative 6.2. That's the second problem you had to do. Are you 2 for 2? And finally, this third problem that you had to do, x plus 4 and 4/7 is equal to 13. Hopefully you recognize that you were adding 4 and 4/7 to the variable x on the left of the equal sign. Therefore, we needed to subtract 4 and 4/7 from both sides. On the left-hand side, these are opposite sign numbers. They cancel and isolate the variable x. Remember, that is the goal of solving equations, to isolate the variable x. On the right-hand side, we have to do a little math. 13 take away 4 and 4/7. We just can't say the answer is going to be 9 and 4/7. That's incorrect. We actually have to borrow from the 13, make it a 12, and then the fraction we will use will be 7 over 7, because we need to subtract 4/7 from it, so we use a denominator of 7 up here. 7/7 take away 4/7 is 3/7, and 12 take away 4 is 8. That was the third problem you had to do on your own in this video lesson. Hopefully you were 3 for 3. We're going to take a look at another part of solving one-step equations with addition and subtraction here. In the next slide, we're going to talk about when addition means subtraction and subtraction means addition. Addition means subtraction, and subtraction means addition. You got to be asking yourself, what is this Mr. Pi the Math guy talking about? Well, let me show you what I'm talking about. And to show you what I'm talking about, I have two examples up here. Let's first take a look at the similarities and differences about these problems. What's similar about these problems? What's the same? Well, one thing that's the same is that they're both equations. They both have equal signs. Another thing that's the same is they both have an x on the left of that equal sign. Another thing that's the same is they both have a 2. Let's talk about the differences now. What's different about them? Well, this problem has a positive 2, and this equation has a negative 2. This problem has a negative 5. This problem has a negative 7. Here's another difference. Between the variable and the number, there's only one sign here. It's a plus sign. Between the variable and the number here, there's two signs, in this case, two negative signs. And this is what I'm going to talk about when addition means subtraction and subtraction means addition. We're not going to worry about this example right now, so we're just going to move it out of the way. What I really wanted to do is illustrate how the second equation over here has two signs in it. If we look at it on the left-hand side of the equation, the equal sign, it has subtract a negative number. We're subtracting, but in reality, this is a case where subtraction means addition. You're really going to want to take the time to rewrite this problem as x plus a positive 2. And that's because we can define subtraction in terms of addition. Or to subtract a negative number, we add a positive number. Now this becomes a very easy equation to solve, as we saw in the last examples. To solve this equation now, we would subtract 2 from both sides. A mistake that kids make a lot of times when first solving these problems is they just want to focus in on the operation itself. And in fact, this gives x is equal to a negative 9. A lot of times students want to focus in, oh, this is subtract, so I'm going to add 2 to both sides. Well, no, in reality, this is really a time where you're subtracting a negative. It means you should add a positive. Notice I decreased the number of signs to 1. This double negative became a positive. Here's another case that you need to worry about. And that case is when you are adding a negative, such as x plus a negative 4 is equal to, say, 9. In this case, a lot of students focus in on saying, oh, this is an addition sign, so I should subtract 4 from both sides. Well, here is a case where addition actually means to subtract. When you're adding a negative number, you probably should rewrite it as x minus 4 is equal to 9. You change that, so instead of having 2 signs, you only have 1 sign. Then you proceed with using your opposite operation. In this case, since it's subtract 4 from x, you should add 4 to both sides. Isolating the variable and getting a value of 13 in this case, x is equal to 13. Key thing though is sometimes addition does mean subtraction and subtraction means addition. It's kind of weird, so in the next few examples I'm going to model how to recognize the two signs and how to change them. Here's some more examples that I'm going to model for you today. And these are examples where subtraction means addition and addition means subtraction. Now obviously if you understand this, you don't really have to go through the process of changing the equation like I am, but if you're struggling with getting the right answer, you may want to take the time. Now if we take a look at problem number 4, where we have x minus negative 5 is equal to negative 7, you should notice on the left of the equal sign, we have a double sign, we have that double negative. We should change that into x plus a positive 5. So we change that to x plus 5 is equal to negative 7. Now that we have these two signs down to one sign, we should easily be able to solve this equation by recognizing the opposite of add 5 is to subtract 5. Using the subtraction property of equality, we subtract that from both sides. On the left, these are opposites, thus isolating our variable x, bringing down our equal sign, and then having negative 7 take away 5. That calculation yields a negative 12. In example 5, we have x plus negative 6.6 is equal to negative 12.8. Again, on the left of the equal sign here with the variable x, we have plus a negative number, a double-signed problem. As I've modeled in the examples on the previous slide and in number 4, we want to rewrite that. And this is a case where we're going to rewrite addition as subtraction. So it's going to be x minus 6.6 equal to negative 12.8. From here, we want to subtract 6.6 from both sides because, we should add 6.6 to both sides because we have subtract 6.6 from the variable x. So when we add 6.6 to both sides, the minus 6.6 and plus 6.6 on the left, they cancel, they go away, giving us the variable x isolated by itself, bringing down our equal sign on the right-hand side. We have to do negative 12.8 plus 6.6, similar to other problems I've already done. They're opposite sign numbers being added, so we subtract their absolute values. 8 take away 6 is 2. I'll put down my decimal sign. And 12 take away 6 is 6, so the number part is 6.2. It is negative because negative 12.8's absolute value is greater than 6.6's absolute value. So final answer here is x is equal to negative 6.2. Our last example involves some mixed numbers and a double sign problem. And in this double sign problem, we have x minus a negative 2 and 2/7 equal to 9 and 3/7. As we saw in problem number 4, we have a double negative here. So to correct that double negative or make it easier to understand, we can write it as a positive number, or as a plus a positive 2 and 2/7 equal to 9 and 3/7. So hopefully now you can recognize that since x is being added to a number, we're going to have to subtract that number from both sides using the subtraction property of equality. Subtracting 2/7 from both sides. The 2/7 on the left cancel because they're opposites, isolating the variable x. And on the right hand side, 3/7 take away 2/7 is 1/7, and 9 take away 2 is 7. So final answer here is x is equal to 7 and 1/7. You're going to have some problems to do coming up next. Solving one-step equations, your turn. At this time, here's the interactive portion of this algebra video. You're going to pause the video and time yourself to solve these 3 problems. These are problems 4, 5, and 6 you've done yourself today. When you're done, you should continue the video and I'll model the proper solutions. So taking a look at number 4 here, we have x minus a negative 7 is equal to negative 18. If we used a technique from the previous slide, we're going to rewrite this as x plus 7 is equal to negative 18. To solve this equation, then on the left, we recognize that we should be subtracting 7 because it's add 7 to the variable x. We subtract it from both sides. Plus 7 minus 7 goes away, cancels out if you will, isolating the variable x on the left-hand side. On the right, we have negative 18, take away negative 7, and that gives you a negative 25. That's the 4th problem you did in this video. Hopefully you're 4 for 4 at this point. And problem number 5, you need to recognize this plus a negative 9.3 can be rewritten as x minus a positive 9.3 equal to a negative 11.2. Now it should be really easy to recognize that since we're subtracting 9.3 from the variable x, we'll need to add 9.3 to both sides using the addition property of equality. These numbers cancel because they become 0, giving us x by itself on the left-hand side. On the right-hand side, we have to subtract the absolute value since we're adding sign numbers. We actually have to borrow in this problem, where we're going to borrow from the 11, it's going to become 10. And this 2 becomes 12, and 12 take away 3 is 9. Decimal place goes there. 10 take away 9 is 1, giving us a 1.9. The sign of our answer is a negative because the absolute value of negative 11.2 is greater than the absolute value of a positive 9.3. Final answer here is x is equal to negative 1.9. I'm hoping you're 5 for 5 at this point. And finally, problem number 6. X minus a negative 3 4/5 is equal to 11 and 1/5, recognizing this double negative, and that should be rewritten as adding a positive. So x plus 3 and 4/5 is equal to 11 and 1/5. You should recognize now, since x is being added to 3 and 4/5, we'll use the subtraction property to subtract 3 and 4/5 from both sides. The 3 and 4/5 on the left cancel, leaving us the x, the variable isolated all by itself. And on the right hand side, we do the calculation. Here we have to do a little finagling with our fractions. 1/5 take away 4/5 we can't do, so we borrow from the 11, it becomes 10. The 1/5 actually becomes 6/5. We have to add 5/5 to 1/5 to get 6/5, and 6/5 take away 4/5 gives us 2/5, and 10 take away 3 gives us 7. That was the sixth problem you were to do in this interactive math lesson. Hopefully, with me modeling and explaining to you, and then you having an opportunity to do your own problems, you can come away from today's math lesson on solving one-step equations with me, Mr. Pi the Math Guy. You have a solid go at your algebra or whatever class you're taking. If this video has helped you, I encourage you to leave a comment or even just give it a thumbs up. Thanks for watching. Bye-bye.